Hi, and welcome to your first Internet of Things tutorial with me, Hanis. And for the first series, I want to talk about this. This is a microcontroller called ESP8266 with Node MCU 1.0 development board. So even though this is quite old microcontroller, however, and has been replaced by the more powerful ESP microcontroller, which is ESP32. However, this microcontroller still being used or um, being utilized to develop Internet of Things solution. Um, But before that, what is basically Internet of Things? So Internet of Things, the name basically implies, which is the Internet of Things. So any things, for example, your phone, um, your computer, your um, this microphone, this is the things. However, when we attach or when the things connected to the internet, which allow them to do more than just their regular function, um, that is things become Internet of Things. However, um, to allow for the things to be able to connect to the internet, a microcontroller will be required. And the microcontroller that usually being used um, in the what we call as in the Internet of Things development usually require chipset that allow them to connect to the internet. And one of the most popular chipset available or being used nowadays is the ESP8266. So the microcontroller is basically the one that's being covered by this metal structure here, the small one. Um, but the rest of the board, this is what we call as a development board. And the best thing about this microcontroller is that you can program this by using Arduino Internet IDE. Um, and you can use Arduino programming language, C-like programming to program this to be able to do its purpose. All right, so let me just quickly show you the microcontroller close on. So the controller basically developed by Chinese company, and it basically comes with number of pins, what we call as an input pins, I/O pins, and input-output pin that allow for the microcontroller to communicate with sensor, with input and output devices. And specifically for this microcontroller, which is the Node MCU, they call it Node MCU 1.0. The development board basically comes with pins, with what we call as a pin out. And each pin out here, they have their own purpose and label through the labeling that if you can see. Okay, so all these pins, not all, most of the pins that available in the development board can be used or can be programmed through Arduino IDE. And today we're going to look how to do or how to program this microcontroller and communicate with with this controller. So just like any other computer, this is a microcomputer, what we call microcontroller, which basically they have their own processor, memory, and also input-output component, and which make this as a full a microcomputer. And this microcontroller can be easily programmed by using USB cable. So what we need is just a USB cable, a micro USB cable connected to a computer. And then we need to install uh, drivers, which is from the manufacturer website, to be able to communicate with the computer. All right. So to be able to communicate with our computer, or to be able to develop or to program by using a computer, so we need to do the following. So we need to go to one of my favorite website. Let's see. So you can go to the following website from Random Nerd Tutorial and follow the installation and how to install ESP8266 board, which is known MCU board, and all the prerequisite component. So follow the installation tutorial from the Random Nerd tutorial, Random Nerd website, and make sure that all the requirement fulfilled. However, you do noted that the version, the installation version available through the website is Arduino version IDE 1.8.9. And the latest version for the Arduino is Arduino, I believe the latest version, version 2. Okay, so you can download the latest version. Which is version 2.1.0, and download for your specific operating system. For Windows, you can download for Windows, and continue with the installation. So once you complete the installation, there are a few configuration required. That configuration basically can be done through Arduino IDE preference. So for example, in version 1.8.9, you need to add the following, what we call it as a board definition, into the additional board manager URL. So let me open up my Arduino. And my version of Arduino is version 2.1.0. And to be able to configure, you need to go to the preference. And from the preference here, you need to update the additional board manager URL, and you can just add the following entry to the additional URL. And here I added a second URL, and this is for ESP32. So if you want to use ESP32, you need to make sure that you install this and add this library into your URL. All right, so once you have that, you can just press OK and wait for the installation to complete, because the board definition library will be required to be installed first. By default, Arduino IDE, they don't come with the board definition, and you need to install the board definition by following the tutorial. So once you install the tutorial, you install the board manager. The one that I use for ESP82 is not from here. I use from different definition, but basically the same. You can just install the same package from the random node tutorial. All right, so once you have your board ready, okay, So once you have your board ready, you need to install the board manager. Okay, you can go to the board manager, which is available through the tools menu, board, and board manager. Okay, so the latest version, the board manager and everything handled through the left side of the IDE itself. So you can just search ESP8266 and you should be able to see the installation. Uh, all you need to do is just install, and I already got the latest version, the board manager package, which will install the board manager to your Arduino. All right, so once you have your board Arduino board manager installed, you need to install the driver. Okay, so you need to install the driver for the for the ESP. So basically, the driver basically available through following website. This one also available from here. Yeah, this one. From this website. So you need to download the driver installer and install to um, your computer. So this is the driver from the website. And make sure that you download the right one, the right version. So for example, for Windows desktop, you can download the 64-bit version here, and then you can just perform the installation and follow the installation guide and make sure that your driver install properly in your computer. So depending on the operating system, for Windows, you can just install for the desktop version and choose the 64-bit version. So if your computer running 64-bit processor, and once you install, you can just check your device manager, um, and to confirm that the device manager properly install your driver. To be able to test that, you need to connect. Okay, you need to connect. Okay, you need to connect the USB cable to your computer, but make sure that you do it on not on a metal surface, not on a conductive material. So like on this table should be okay, because all the pins here, this is all basically they have their own. This is all metal. So if you connect this or you put this on a metal surface, any power pins that basically here there's a number of power pins here, they basically contact, and then you might short circuit your board. So just make sure that you don't do that. Make sure you put it on a surface that's not a conductive surface. Right, so once you have that, you need to check your COM port here, and this is basically the one that you need to look for. For ESP8266, you need to look for Silicon Labs CP210X USB to UART bridge, and COM port number might be different with yours. In my case, my COM port number is COM port 3. So this is basically the COM port for my computer, and yours might be different, COM1, COM2, COM4, but it should be no problem. But as long as there's no problem with the installation, the driver installation means that your computer now are able to talk to the microcontroller. So once you're completed with the installation, now you can test your installation and make sure that your installation is working. And to test your installation, you can just create new sketch, because I already have sketches here. And you can try a very simple sketch available through your Arduino codes. For example, I can just go to basic, can just go to digital blink, where, let me check first, analog, this one, basic, read this one, blink. Okay, just go to example, file example, basic blink. Right, so this is a very basic codes that you can use to learn about Arduino. So this code basically will blink your Arduino and your Node MCU, and it shows that, just to show that your code is working, your development environment is working. All right, so to test for IDE 2.1, anything that version 2, you need to make sure that to choose your board. All right, so for here, if you are not, you need to make sure that you select the right board. So in our case, it's version 1.0 ESP12E, and select your correct board. So for my computer, it's version COM3. So press OK. So make sure that this is available. And to test the installation, all you have to do to test your development or your driver installation and everything, just press this upload button and wait for a while. So it's you can see the output down here through this output terminal, and you can see that there's a stages writing percentage, and this is basically to show that the process, it is basically working, right? So it start with the definition for the board itself, um, and then also the process to upload the codes, Arduino codes here, to your microcontroller. And when it reach 100%, and leaving with hard resetting via RTS pin, and you can see the result on your microcontroller. So as you can see here, you can see the LED now is basically blinking. Okay, so means that the codes from Arduino IDE successfully uploaded to this microcontroller, and the built-in LED, as you can see, there's an LED there. There's a two LED basically. There's the LED basically on the microcontroller itself, and there's a LED also on the development board, non-MCU development board. But the codes, the example codes, basically are doing this. The LED is basically blinking. Okay, and let's take a look at the codes, the basic codes for IDE, for the operation. For Arduino IDE, so basically there are two main functions. There are two functions here. All the gray section here, that's basically command. So it's not going to take care, it's not going to be compiled into your program. This is just a command for your programming. And you can write anything, comment, notes, and whatnot. But the most important things that you need to look in the programming, in Arduino programming, is these two functions here. So the functions basically described in these two blocks. One is called setup function, and the other one called loop function. So the setup function here basically only run once. Okay, and it basically used for definition, variable, define variable, define the pin out as an input or as an output. We initialize value, and the way that the Arduino programming work is that it work as a sequential programming. So the setup will only run once, and anything that we require to run once runtime will be put inside this setup function. However, the second function here is called loop function. This is where we want our instruction to run as as indefinite loop. Okay, so the indefinite loop here will loop forever until the power goes off. So the instructions, every line that we see inside the loop function, okay, when we talk about function, okay, the function definition always start with either a written value or non-written value or void written value. So there's void here means that it written nothing and will only execute this function name, anything within this what we call as a curly bracket, open curly bracket, and this closed curly bracket. That's basically a block of function. So anything inside here will be executed line by line, and the instructions for this is just a very simple instruction. Um, Again, in the setup functions, so we need to define the pin mode, and the pin mode here basically define the pin mode operation. So we can define the pin either to set the type of pin operation as an input operation or as an output operation. And the pin mode for LED built-in that's basically available or predefined in Arduino in Node MCU, basically connected um, to pins pin number uh, to a certain pin number. Okay, so as you can see here, um, when we hover on top of this LED built-in, it's basically defined LED built-in pin number 2. Okay, there's a pin 2 there. So if you look at the Node MCU, you look at pin out. Okay, so the pin out for Node MCU. So pin number 2 is not referring to the D. D is for digital, and the pin number is basically depicted here. So pin number 2 is down here. So which means that this pin GPIO2 basically connected to the LED pin. Okay, they are connected to the LED pin. So when we define the built-in, okay, we define the LED built-in. This is basically has been defined, predefined as LED2. And we define this as an output, means that we want to an output a value, all right, certain value, and we define it in the setup mode. However, in the loop mode, we use what we call as a digital write. So digital writes means that we want the output. Okay, we want to write something or a value to the specific pin. So when we give the instruction digital write means that we want to write value to the LED build pin that we have defined up here. We define as high. So high value is on. Okay, we turn on the value. We set the value high. Set the voltage high. Okay, so we set the voltage high, and when the voltage set high, the LED will turn on. If we set the voltage low, and then we set a delay function here, we will delay for 1000 millisecond, which is 1 second. And then we run the instruction again, set the LED built-in to low, and then we delay again for another 1 second. So that's why you get this strobing function, strobing operation. High, low, high, low, high, low. So on, off, on, off, on, off. As long as there's a power to the board, the LED will do that operation. And this is basically how Arduino programming works. So you set up the function for pins, and then you set the operation in the loop function. All right, so this is just a very fundamental. So I'm not going to go more details. Just get yourself familiar first with the installation, with the IDE, and also make sure that when you connect or when you use your Node MCU, the driver detected, properly installed in your computer, so that after this we can start with the programming. Okay, we can start with the IoT programming, and we can work with the microcontroller and perform a much higher function, much desired function. Okay, so I think that's all for today for this simple tutorial. So get your IoT journey begin with Node MCU. Definitely, it's not just Node MCU or the ESP8266. You can also use a ESP32, which is basically the same. The only thing is that you need to make sure that the board definition here set up for the ESP32, as you can see up here. But for ESP32, make sure that you select the correct version for that particular board, because there are a number of ESP32 for non-MCU for the ESP32. Right, so we put it at ESP32 there. Quite a number of ESP32 board available. Right, so make sure that you choose the right one. But for non-MCU, for ESP8266, also there's a number of ESP8266 available. Low-lean version, VMOS version, Pointnik version, SparkFun version. It's quite a lot. But the one that the most used, the most accessible is Node MCU 1.0, and the one that I've shown to you. Yeah, and then you can just easily get the board from Shopee, very cheap. It's like Node MCU. Look from Shopee, available from Malaysia website. So the cost is quite low. It's about like 16 ringgit only. But make sure that you get the correct version. The one that I use, my favorite version is Node MCU version 2. Don't get the Lolin version, because Lolin version is quite big and it's not breadboard friendly. So use the one that version 2 board, and it's quite small, and it's basically but if you want to have like with a cable, so you can buy this version without cable. But Lolin version is quite big, and then they use a different driver, which is CH340. um, if you want to buy ESP32, it's only like 30 ringgit, but for non-MCU, it's only 20 ringgit. Okay, not that much in terms of the cost itself. All right. So you can read more on the website um, render node tutorial, and later on I'm going to talk more on the node MCU and how can we use node MCU in IoT programming, because node MCU or ESP8266, they comes with Wi-Fi, and this is Wi-Fi antenna here. This is Wi-Fi antenna here that you can use to connect to Wi-Fi router. All right. So this is basically a true IoT microcontroller where you don't have to connect to Wi-Fi chip. It comes pre-built in with Wi-Fi. All right. So go get yourself one and learn IoT by using this microcontroller. It's very fun to learn. All right. So all right, so with that, see you in the next tutorial.